Google DeepMind has just released a massive update to AlphaFold, and they are offering a free proteomics service to the world. But the real story here is not about biology or protein structures. The real story is a fundamental shift in how we think about the economics of AI hardware. For years, we have operated under the assumption that you need massive clusters of graphics processing units to run any serious artificial intelligence work. That dogma is finally breaking. By the end of this video, you will understand why the future of production AI depends on specialized chips rather than general-purpose GPUs, and how this changes the entire cost structure for engineering teams. When you look at the latest release from Google DeepMind, you see the introduction of native support for NVIDIA Blackwell GPUs. This is not just a routine update, it is a signal that the industry has moved past the era where any powerful GPU could solve every problem. The new AlphaFold 3 pipeline integrates a library called Tokamax. This library provides optimized flash attention and SwiGLU implementations that are specifically tuned for the underlying silicon architecture. The result is that inference performance is now tightly coupled with specialized hardware rather than generic compute clusters. Consider the implications for a junior engineer building a production system. You might have spent years learning to scale on CUDA cores, assuming that throwing more GPU horsepower at a problem would always yield better results. But the data suggests otherwise. The bottleneck in modern AI has shifted from model training to inference latency. When you are running high-throughput production pipelines, the cost of waiting for a general-purpose GPU to process a query can become prohibitive. Specialized accelerators, like the TPUs and ASICs that Google has been refining, can handle these specific mathematical workloads far more efficiently than a standard graphics card. This shift is becoming visible in the real world through adoption metrics. The repository for the AlphaFold 3 inference pipeline has already accumulated 8,000 stars and 1,200 forks. These numbers tell a story of developers actively testing and deploying these new tools. But the story does not end with open-source code. Google has simultaneously launched a free, non-commercial web application for proteomics. This is a strategic move to normalize AI-driven proteomics as a scalable service. By offering a managed service, they are abstracting away the heavy lifting of specialized hardware utilization. This allows organizations to validate their return on investment on TPU or ASIC-backed inference without needing to make massive upfront infrastructure investments. Quick resource note: I keep a curated set of Amazon search links in the description for books, gear, and tools relevant to this channel's topics. Some are affiliate links, so I may earn a commission at no extra cost to you. Please consider supporting the channel by using those links if you find something useful. Here is the thing that often gets missed in the excitement. While the service is free for non-commercial use, the underlying requirements for running this system locally remain steep. To run the full inference pipeline on your own hardware, you still need substantial local resources. You are looking at 3 terabytes of disk space just to store the necessary model parameters and data structures. Furthermore, you still need modern NVIDIA hardware to achieve the performance that the specialized libraries promise. This creates a fascinating paradox. The democratization of the technology is gated by infrastructure costs that are still out of reach for many independent practitioners. The distinction between the open-source version and the managed service is critical for your engineering decisions. The open-source pipeline, version 2.32, gives you the code, but the parameter-restricted version 3.02 for inference operates on a different set of rules. There is a knowledge gap regarding whether the hardware optimizations found in the Tokamax library are universally applicable or if they are limited to the proprietary web service. This uncertainty forces engineering teams to make a difficult choice. Do you invest in building your own specialized stack to match the efficiency of the cloud service, or do you rely on the managed platform and accept the limitations? The inclusion of improved error messaging and chirality checking in the latest release highlights another crucial point. Production-grade AI reliability now depends on these hardware-aware optimizations. General-purpose frameworks simply cannot handle domain-specific constraints as efficiently as specialized libraries. When you're building systems that must be reliable, the difference between a generic GPU and a specialized accelerator is the difference between a system that works and a system that fails under load. This is why the industry is moving towards specialized hardware. The cost-benefit ratio for independent practitioners versus enterprise deployments is shifting rapidly. Think about the hardware economics. In the past, the cost of running AI was defined by the price of GPU clusters. You bought more cards, you got more speed. Today, the cost is defined by the efficiency of specialized inference chips. If you are building a production system, you are no longer just buying compute cycles. You are buying architectural alignment. The era of the GPU-first dogma is ending because it is no longer the most economical path for scaling AI workloads. Specialized hardware accelerators are proving that they can outperform general-purpose GPUs on specific mathematical workloads that are critical for modern applications. This realization changes how you should approach your career and your projects. If you are a software engineer, you need to stop thinking of hardware as a commodity. You need to start thinking about how your code interacts with the physical silicon it runs on. The tools available to you, like the Tokamax library, are designed to exploit the unique properties of specific architectures. Ignoring these optimizations means leaving performance and cost on the table. The future of AI development belongs to those who understand that the hardware is not just a platform, but a critical component of the algorithm itself. The release of the free web app alongside the open-source code is a clear signal of where the industry is heading. It is a move to normalize the use of specialized hardware for production tasks. It suggests that the heavy lifting of infrastructure management is being taken over by the service providers, allowing engineers to focus on the logic and the results. But for those who choose to build their own systems, the requirements are higher. You must understand the nuances of flash attention, the constraints of chirality checking, and the specific demands of the Blackwell architecture. The path forward is clear. The GPU-first assumption is no longer valid for high-throughput production pipelines. The industry is pivoting toward TPU and ASIC specialization. This is not a temporary trend. It is a fundamental change in how we calculate the cost of intelligence. As you evaluate your own projects, ask yourself if you are still relying on legacy assumptions about hardware. The data shows that the most efficient path forward is through specialized accelerators. The technology is here. The tools are available. The only question left is whether your team is ready to make the shift. Thanks for watching all the way to the end. I am a one-person team working hard to make each video better than the last. Subscribe if you found value. It is the best way to show support. Drop a comment with your biggest takeaway. See you in the next video.